Hi, I'm Teacher Thomas. Welcome to A-Level Maths. This is the specimen paper for 9231 Pure Mathematics 1 for the 2020 exam series, question 4. The cubic equation, z cubed minus z squared minus z minus 5 equals 0, has roots alpha, beta, and gamma. Requirement A, show that the value of alpha cubed plus beta cubed plus gamma cubed is 19. I'll begin by listing some relationships I need to work with the analysis of roots of polynomials. Alpha plus beta plus gamma equals negative b over a. Alpha times beta plus alpha times gamma plus beta times gamma equals c over a. And I need two recurrence relationships. The general recurrence relationship is S sub n is alpha to the power of n plus beta to the power of n plus gamma to the power of n. We're going to need S sub 1 and S sub 2. S sub 1 is alpha plus beta plus gamma, and S sub 2 is alpha squared plus beta squared plus gamma squared, which is a component of the expansion of alpha plus beta plus gamma squared. It is that expansion less 2 times alpha beta less 2 times alpha gamma less 2 times beta gamma. Notice we're working with two different alphabets. We're working with alpha, beta, and gamma, as well as A, B, C, and what is not yet written but is in the analysis, D. Those letters, A, B, C, D, are the coefficients of the cubic, quadratic, linear, and constant terms. So looking at our equation z cubed, the coefficient is A, that is 1. Z squared, the coefficient is B, negative 1. Z, the coefficient of z minus z, is negative 1, and d is our constant value, negative 5. What I'm working towards is finding the value of S3. That's the requirement. Alpha cubed plus beta cubed plus gamma cubed. If we look at our general recurrence relation, S sub n, that equates to S sub 3. The way I'll find S sub 3 is by setting up an equation using the cubic that we're given. I'm going to, in this equation, replace the z's with s's. In the cubic we're given, z cubed, or 1 times z cubed. I'll replace that with 1 times s sub 3. Minus z squared, I'll replace with minus 1 times s sub 2. Minus z, I'll replace with minus 1 times s sub 1. Minus 5, I'm going to replace with minus 5 times 3. The 3 multiple represents we're working with a cubic, and when we're using summation for a cubic, we would be adding 3 different equations to represent the 3 different roots of a cubic. And this equation equals 0. Now we'll calculate S sub 1 and S sub 2. S sub 1, I see on the left, is alpha plus beta plus gamma, which is the same as negative b over a. I have the values above for b and a, so negative b, negative 1 over a, which is 1, simplifies to 1. On to S sub 2. Referencing S sub 2 in the lower left of the screen, I see the first component is alpha plus beta plus gamma squared. We've just calculated alpha plus beta plus gamma as 1, so we have 1 squared, minus 2 times, and here I'm going to factor out the negative 2, alpha beta plus alpha gamma plus beta gamma. Now on the left we see that this expression equates to c over a. So I'll replace this expression with c over a, continuing to simplify. 1 squared is 1, minus 2 times c over a. Looking at the top of the middle section, c is negative 1 over a is 1, which simplifies to 1 minus 2 times negative 1, or 1 plus 2, is 3. And now we're ready to solve for s sub 3. On the right side of the screen, 1 times s sub 3, or s sub 3, minus 1 times s sub 2. We've just calculated s sub 2 as 3, minus 1 times s sub 1. We've calculated s sub 1 as 1, minus 5 times 3, which is 15, equals 0. And now we can simplify to s3 equals, moving all three constants to the right and changing the signs to positive. We have 3 plus 1 plus 5 is 19. Recall that s sub 3, using the general term for s sub n, equals alpha cubed plus beta cubed plus gamma cubed equals 19. That completes the requirements for A. Let's go on to part B. Find the value of alpha to the power of 4 plus beta to the power of 4 plus gamma to the power of 4. Similar to the process of solving for s sub 3, I'm going to replace my cubic terms with recurrence terms. Here, since we're looking for to the power of 4, I'm going to replace the first term, z cubed, with s sub 4. So in our original cubic, we had 1 times z cubed, so I'll write 1 times s sub 4, minus z to the power of 2 will become minus 1 times s sub 3, minus z will become minus 1 times s sub 2, minus 5 will become minus 5 times s sub 1 equals 0. Notice that in working from sub 4 down with a cubic, the constant term minus 5 ends up with a multiplication by a recurrence term, s sub 1. And as a result, there's no need for a multiplier adjustment like we did when we were solving for s sub 3, and the constant term negative 5 wasn't being multiplied by a recurrence term. We can solve for s sub 4 using the other recurrence term values from part A. S sub 3 is 19, so minus 1 times 19 is minus 19. S2 is 3, minus 1 times 3 is minus 3. And S1 is 1, minus 5 times 1 is minus 5 equals 0. Simplifying to S4 equals 19 plus 3 plus 5, which equals 27. Thus, the sum of alpha to the power of 4 plus beta to the power of 4 plus gamma to the power of 4 equals 27. That completes the requirements for part B. Let's move on to part C. Find a cubic equation with roots alpha plus 1, beta plus 1, and gamma plus 1, giving your answer in the form px cubed plus qx squared plus rx plus s equals 0, where p, q, r, and s are constants to be determined. Recall that our z roots are alpha, beta, and gamma, and now our x roots are alpha plus 1, beta plus 1, and gamma plus 1. Looking at just the first root of each variable, alpha and alpha plus 1, if we were to add to z a plus 1, then alpha would become alpha plus 1, which is equal to one of x's roots. Thus, z plus 1 equals x, and z equals x minus 1. Now let's go to the original cubic. We'll replace z with x minus 1, which will give us x minus 1 cubed minus x minus 1 squared minus x minus 1 minus 5 equals 0. When we expand and simplify, we arrive at x cubed minus 4x squared plus for x minus 6 equals 0. The coefficient of x cubed is p. P equals 1. The coefficient of x squared is negative 4. Q equals negative 4. Coefficient of x is 4. R equals 4. And our constant term is negative 6. S equals negative 6. This completes the requirements for C, which completes the requirements for question 4.